Okay, you guys, let's get started here. This is our project. It is due Friday. In 2010, we had a different winter break, so that's why it was due then. So ignore that. Let's look at this. Then you'll have to do it over break. I didn't think you wanted to do that. Thought you wanted to be done and not have anything over break. Okay, we've been investigating the series, this one. And we know that that one is geometric. And we've been looking at other series that are related to that. They're part of the family. In fact, we know that the interval of convergence here is actually, excuse me, the radius of convergence is equal to 1. Okay, Grant? The interval, you must check the endpoints. No, it's all in there until we get to things that'll matter. Okay, so I go through, the first part talks about the geometric series and what we've done. Then it says, Taylor and Maclaurin decided to investigate further. Because you know what? E to the x is not related to 1 over 1 minus x. Okay, Eric? You can do derivatives and integrals of 1 over 1 minus x. A lot of times you can get the log function by integrating this. You can get a variety of functions, but you're not going to get sine of x, cosine of x, tangent of x, e to the x. You're not going to get those. Okay, you guys? You're going to have to memorize some of these Taylor polynomials. So they said, well, how else could we generate a different power series that's not related to the geometric one? Okay? Okay, Eric, is that okay? So what he looked at was, here's a function. I don't care what the function is. I'll be doing some crazy things, folks. Let's just do that. And at a particular point, call it A. What has to be true about the derivative at that point? This is f of x. Well, sorry. Maybe we change that. This is my polynomial. You can call it t of x or p of x. I'm going to call it p of x. It doesn't really matter. Now, if this is going to be a good approximation to f of x, what has to be true about p of a and f of a? They have to be the same. But then what do you think also must be true about the slopes there? The first derivative at a and the first derivative of this must be the same. So p prime of a has to equal f prime of a. What about the concavity? They've got to be the same. I mean, if I'm trying to put in a function that looks like this, I want it to be very close to that. And it may not do that after I get far away from A, because these series will converge quickly. And you can approximate e to the x and sine of x, all those other ones, with this Taylor polynomial. And that's how your calculator works. So why not? Okay, Eric, what's true with the concavity here? The concavity of both polynomial and the function must be the same. Well, what do you think about all the derivatives? What about the nth derivative at a and the nth derivative at f? At a. They got to be the same. So using this information, you can find some approximations to the curve. Is that okay, Marshall? Have you looked at this? If you looked at it, it should make a little bit of sense. Okay, so let's start with the cosine of x. Yeah, I'm working with you right now. This is your project. So y equals the cosine of x, or f of x equals the cosine of x. And we are going to center this at 0. Can we find a power series that's equal to that function? Can I write the cosine of x as some sum of powers? Okay, Lizzie, can I do that? Have you started this yet? I'm helping you with it, so you should be doing this. And it's due on Friday. So I think I would use that time for that. Okay, first let's graph this. Now it says to graph, so read the directions because you're going to get points for your graphs. If you don't include the graphs, you don't get those points. So here's the cosine function. Okay, Ori? We're going to do the first problem together. And I want to write the equation of the tangent line there. We can go to the second problem. What's the answer to the first problem? Remember, the linear approximation, and if you remember in chapter 3, we did this. I said, because it was y minus y1 equals m, x minus x1, and we called this f of a, in this case it could be 0, equals f prime of a, and then it's x minus a. We solve for y. And I said it's kind of nice to write your tangent lines in this form because it leads us to these power series later on. There's a pattern here. And that's what they do. They call it L of x. Okay, so it's going to be f of 0 in this case plus the derivative at 0, and then it's x minus 0. Well, what's the equation of that line? It's 1. Because what's the slope here? Now, I know what it is because I've drawn the picture, but what would you have to do? You'd have to find the derivative of this. You'd have to find y prime. What's y prime equal to? Negative sine of x. So what's y prime at 0? It's 0. Now, you're not going to leave them with sines and cosines in there. You're going to evaluate them. So that's equal to 0. Okay? So L of x for the first problem is equal to f of 0, which is 1. Yes, I expect to see the graph. There it is. Now, if you, by the way, take a side point here, with the graphs, you can get the CAS Inspire calculator program for your computer for free for 30 days. So if you want to do your graphs on there, that's fine. If you want to do them by hand, because you can't find an app or anything that will do them, Excel should do them. But the reason we want you to actually type this up and make it look nice is we're trying to get you ready for college, because they're going to expect that. You can't do it by hand. You're going to get 2 class periods to be in the lab. You should type it up, yeah. Yeah. Yeah, we're in the lab the next 2 days. But the point is, in college, you know, I haven't been to college for a while, and I haven't taught college since 1998. But things have changed now. I would think, and we could ask anybody who's in college, or maybe somebody knows, do you have to type up your reports? You may, however, because you can't do that here, but if you have internet at home, you can get the TI Inspire software for free. You have an Inspire software. If you just go to the computer software, type them in, and it does the Taylor polynomials of the CAS. And print it out. It's gorgeous when you do it. Okay? But we're not doing this just for the mathematics. We're doing this to get you prepared for projects, because they're just going to hand you the piece of paper and they're going to say, go do it. Then you get a group of people together, you sit down and you talk about, okay, what's expected here? What do I have to do? And it isn't the divide and conquer either there. Because if you do that and you're trying to do question 5, you didn't do 1 through 4, you're in trouble. Because you don't know what's going on. So it doesn't work that way. Okay. This is the wrong sheet. I don't want to put that one. Okay. I want this one. So 1 is kind of done. Graph both the linear approximation and the cosine of x, and we're going to look at this centered at 0. Could I have done this problem, because this centering part is kind of confusing, could I have centered this over here? The equation of that tangent line is not 0. The slope of that tangent line is not 0, but I could find a linear approximation at this point. That's what you mean by centering. Where are you going to try to set up your approximation? We always hope they're at 0. And that's called a Maclaurin series, when you center them at 0. If you center them anyplace else, it's Taylor. Yeah, is that a good approximation? Lizzie, you have class time. I don't want you to have to take this home. You might have to take it home to get the project part done, but then to get it written up here. Okay, guys, do you think we can find a better approximation to that? Yeah. Couldn't we maybe try a parabola? Parabola looks pretty good. Of course, the further I get away from 0, the less good it gets. If I put an infinite number of terms in my power series, I'll have it exactly equal to the cosine function. and it will converge for all values. That's kind of cool. No, you were drawing. Okay, so question 2, have you tried that one? Question 2 is where you start to see some patterns. Christmas. Okay, so we have y equal the cosine of x. I don't know. I didn't get those for football games. Okay, and here's our approximation. We call it q of x. You can call it anything you want. Who cares? Well, you needed to hear the question 1 to understand 2. Yeah, but I'm not convinced that you understood it. That's why I went over it. Okay, we are going to try to figure out what these constants are. Did I get that? That's our goal. You see the power series there. It's x minus a to different powers. Your job in question 6, I think it is to do n of these and come up with the formula. You cannot prove it, but you're going to have to do a number of these, what I'm going to do right now, 4 or 5, and then you'll see the patterns. And then you'll be able to come up with that general formula. Some of you will look it up and find the formula, but you don't get your points unless you can show me how that formula comes about. Okay, so we know that f of 0 is equal to q of 0. Okay, let's use that. This is f of x. Okay, what's q of 0? Oh, and we're gonna, oh, by the way, we're gonna do we're gonna do this at 0. Okay, that's okay. What's q of 0 is equal to c0. I don't want. Now we're gonna center this at 0. So I want to change my q of x so it's centered at 0. So q of x, I'm going to say centered at 0. This is at any point on my curve. I want it to be centered at x equals 0. It's going to be c0 plus c1 times x plus c2 times x squared. So what's q of 0? It's c0 plus c1 times 0 plus c2 times 0 squared. And I know that has to equal f of 0. So this is going to be, what's this going to simplify to be? No, c0. So c0 equals f of 0, which is the cosine of 0. Whoops. I don't like the way I wrote that at all, so let me fix it. What's the cosine of 0? So c0 is equal to 1. So the initial function, this initial condition, gives me the first term in my power series. Now I want to find c1. Okay? So to find c1, I'm going to use this fact, that f prime of 0 equals q prime of 0. Now f of x is the cosine of x. What's f prime of x? Negative sine of x. So what's f prime of 0? Negative sine of 0, which is 0. Okay. Now let's do the next one. What was my q? Q of x, we're trying to find what c1 is. Q of x, it's barely up here. Let me rewrite it. It's c0 plus c1x plus c2x. What's q prime? What's the derivative of my approximation? What's the derivative of c0? What's the derivative of c1x? It's c1 plus, oh, sorry, x squared. Don't multiply these out. It's 2c2x. Because you can't multiply it out. When you get into the higher order terms, don't multiply them out. Leave them as a multiplication problem, and you will see something happen. So now what's q prime of 0? It's c1 plus 2c2 times what? 0. That goes away. So what's c1 equal to? C1 is equal to 0 because these must be the same. Oh, we got to do this again. Because I still need to find C2. So when you do question 6, you cannot stop at 2. Question 6 is asking for the nth term. Do enough until you see what's happening. You may have to do 5 or 6 for the light bulb to come on. If you do it, the light bulb will come on. Now, you're going to memorize the Taylor polynomial and you'll learn how to apply it. But it's kind of nice to know where it came from, I think. Okay, so let's look at the next one.
Do you have any projects this year?
Yes. Okay. Now, the next one. Yes. We need to show that f double prime of 0 equals q double prime of 0. Okay. What's f? Now, you guys, you have to write out f prime of x. Okay, you guys over there? If I have f prime of x is equal to negative sine of x, what's f double prime of x? Negative cosine of x. So what's f double prime of x? 0, sorry, is negative cosine of 0. What is that, Ori? Negative 1. Well, he beat you to it. Okay, let's do the q's. I have q of x is equal to c0 plus c1x. I'm going to repeat myself. It's okay. What happens to q prime? That's gone. No, I'm doing it just to make sure we got it. Plus 2c2. Because what's going to happen is you're going to write them all out. You'll write out 5 of them in a row. Yeah, let's derivative that. What is that? 2c2. And so what's q double prime of 0? What's the second derivative at 0? It's 2c2. There aren't any x's there, so I don't have to worry about it. Is that okay? What's true about these two values? These are the same. So I'm just going to solve an equation because it's just they're the same. Yes, I am. You will see when you get to 8 terms, keep going and do the 8th derivative going through there. You will see what happens. And that's the bulk of the points of the project. So if you just come up with a formula, you're not going to get those 8 points. You'll see a way to show it. You'll find C8 then. I would just keep going. This is only a quadratic, so I ran out of terms. But if I had 8 terms, I keep going, and I keep track of those over there. Just, you have to show it all. I start with the first derivative. Yeah, you're going to have to keep, it's the nth degree polynomial. Do as many as you need. You might go further than 8. No, not for that. Not for the last problem. When you do the general one. Okay, so negative 1 equals 2c2. And so what's c2 equal to? Negative 1/2. Okay, you guys, let's put this together because this is still not done. I just found the coefficients. Okay, Ori? Eric? I'm going to put this right in here. What was C0? Let me write it down here. Q of x, because then I can slide my board. This is the only problem with the smart boards. Oh, maybe not the only problem, but it's a problem. Okay, what did you find C0 to be? That was 1, wasn't it? What was C1? That's 0 times x, and then it's minus 1/2 of x squared. So q of x is equal to 1 minus 1/2 x squared. If I wanted to go out 2 more terms, I would still have this part. It's not going to go away. You're still going to have this, and you're going to do more. Now, does that make sense? here's my cosine curve. What does negative 1/2 of x squared look like? When x is 0, what's the y value? We said it had to be the same, didn't we? And then I'm going to do minus 1/2 x squared. Now it's probably going to do something like that. And you include a picture. You include a picture for everything to be safe. Yeah. What do you think we can do better yet? Why don't we do the third derivative, and the fourth derivative, and the fifth, and the sixth? You're supposed to do, I don't know. Keep setting it down over here. That's question 2. And then read the details. It says graph. And then you have to find out how close they are. You want the error here to be less than 0.1 on your graphing calculator. It says graph y equals cosine x minus 0.1, cosine x plus 1, and your polynomial approximation on a common screen. I think you'll see that. So question 4 is generalizing what we just did for the cosine for any function. And question 6 is generalizing what we did for any number of terms, n. Question 4 is a quadratic. Question 6 is n number of terms. Question 5 is in particular doing the function square root of x plus 3. Be careful with your numbers. Just do what it says, you'll be fine. Yeah, question 3 tells you what to do. Do you have the graphing calculator? You've got to graph it. Well, right now you're just doing it, and then you'll type it up. We probably could. I know Mrs. Hersman canceled it, but it probably opened in the media center. But I thought you still needed time to work on by hand. Okay, when you do a project in the real world, you don't just go to the computer. You work things out, then you go to the computer. So I think you have a lot of stuff to do by hand, and we don't need to be in the lab. It's up to you. Okay, now those of you who had some questions who were further along, did I somehow answer some of them? And that's cool when you figure it out. Those of you who are too lazy and look it up, you lost out. You got to do exactly what I did, except this time you're going to do this. Q of x is equal to C0 plus C1 x minus a plus C2 x minus a squared plus, that's your polynomial, you call it P of x, L of x, I don't care what you call it. C3 x minus a cubed. Oh, you're doing the square root one? Is that the square root? Why does that not show up? I can do it this way.